Hi, folks. So, welcome to what we're hoping will become a series of Emergence technical podcasts and chats. And on this first one, we want to focus on one very specific thing, which is memory for AI agents and long term memory and conversational memory. I'm your host. My name is Vivek Haldar. I lead some of our AI engineering teams here at Emergence. And let's quickly go around the room, do some quick intros before getting into the topic at hand. Paul, let's start with you.
Hi, Paul Haley. I'm a fellow and distinguished engineer in R&D here at Emergence.
Marc,
Marc Pickett. I work on long-term memory.
Jeremy,
I'm Jeremy Hartman. I work on planning and memory at Emergence.
Prakhar.
Yeah, hi. So I'm Prakhar. I am working as a AI research intern and working on long-term memory. Yeah.
Awesome, fantastic. All right, so let's get right into it. We really want to focus on memory and how it's used in AI agents and why even it's important for AI agents. So before we get into the result, Emergence published a really cool result on achieving state-of-the-art results on LongMemEval, which is the current best benchmark for memory. Let's set the stage a little bit about what exactly do we mean when we talk about memory, long-term memory, and why is it so important for AI agents? Why should a company that's building AI agents even care about memory? So let's start with that.
The way I view it is that if you're working with an assistant or a coworker, you want to work with them for a long time, months or even years. And if you have a new employee at your company, or if you hire a personal assistant, you don't expect them to be very productive their first day or possibly even their first week. There's going to be some time where they learn the ropes of your situation. So they're going to learn, oh, this is how we do things here, or oh, this is the kind of email you have, or you tend to send these messages via Slack, or oh, this is the specific kind of project that we're working on. So all kinds of knowledge bound tasks, and I say knowledge bound in the sense that no amount of thinking or reasoning is going to make you understand, for example, that your database is a MongoDB. That's just something you just have to learn and know. And you could try to code all this up in a document, for example, but there's a lot of this knowledge is tacit in the sense that, okay, I'll try to code up all the knowledge I have, but there's a lot of it that it's just something that just comes out of interaction of working at the place. And so you want your assistant to, if you're using a language model, for example, the language model only knows what's in its context window and what's in its weights. What's in its weights are probably what's pre-trained at OpenAI or Google, and that's general world knowledge. But the specifics of your situation are either in the context window or we have to fetch it and store it and put it into the context window. So that's where long-term memory comes in. It's that process of knowledge that's specific to your situation and learning the ropes and organizing that and putting the right information into the context window at the right time.
And I'll be a little bit more specific about the benchmark and, in particular, not memory in general. So if you think about RAG, where we put passages into some memory from which we recall and put those passages into context to help something answer questions in a grounded way, that's a form of memory. Conversational memory is a little different. Conversation is longitudinal, it's got sessions, if you will. And those things appear in the LongMemEval benchmark, which is specifically focused on conversation. So, what we know, published in our results, for example, but we knew this before we did the benchmark, is that it doesn't take many turns of conversation to overwhelm the ability of a language model to attend to all that conversation and reason about some of the things that Marc was talking about. You can't put thousands of turns of conversation in and expect the language model to understand it. And there are other problems with that. If the more you put in, the more expensive it is, the slower it is, And again, its attention will be overwhelmed. So you need some means if you're going to learn or be able to use your historical conversations with your language models. You need a memory of those conversations and a means of getting what matters out of that history of conversation or abstractions or extractions thereof into context. That's memory, whether it's conversational, whether it's document centric, and there are other forms and types of memories.
So in addition to enabling learning, memory enables personalization, and that's crucial for us. We focused on personalization for this benchmark at the individual level, but we're also interested in kind of personalization at the company level or institutional level.
So that's the perfect segue to my next question, which is that, okay, why is this kind of conversational memory and long-term memory really crucial when deploying agents for the enterprise?
If you don't remember your conversations with the team at an enterprise, you're going to be starting from scratch every time you have a conversation. That's one thing. That's not very productive. I think it's that simple, frankly.
And one of the tenets is this is institutional knowledge. If, again, with the assistant metaphor, the user should never have to repeat themselves. I know that when I'm working with an assistant, even ChatGPT, which has a form of long-term memory, I start getting annoyed when I have to copy paste things. Oh, I told you this 50 turns ago. Here you go, copy paste. Oh, you forgot what we're doing. So in general, if you have an assistant or an agent that's working for you, that's just a good ability for it to have, that you don't have to keep repeating things.
Yeah, I also think there's a lot of information stored within the distributed brain of any company or institution. So some process that I have done frequently might be usable by another person, and we want to enable that kind of knowledge sharing and procedural knowledge sharing across the company. The challenge is to do that in a way that preserves the privacy of the users while at the same time allowing for that kind of knowledge transfer.
So I have one more point. As we were talking, so what we also put in inside memory matters a lot, like the context which we put in. Because if we put something which is irrelevant for a particular enterprise or industry, we might have something known as context rot. So basically, whatever you put in, as Mark said, we don't want anything which repeats itself, right? While the conversation goes in. So we need to also avoid the context rot inside the memory, and so that is why context engineering is also a very important aspect when we come down to what we are going to store, like which relevant things are we going to store and how we going to retrieve. So yeah.
Yeah, that makes a lot of sense. So let's dig into some of the recent results we published. We leave links to all of these in the description below. But in a series of blog posts on our website, emergence.ai, we recently published state of the art results on LongMemEval, and we beat the previous best, which was about 71% by quite a bit. We achieved 86%. So before we even get into how we achieved that result, can you explain a little bit about what the benchmark is? We did this on LongMemEval and what exactly it's measuring, and then we'll get into how we achieved the result.
So one thing that LongMemEval is not, and I'm parroting sort of a blog post from Calvin Koo, a blogger, it's not a needle in the haystack. And so Calvin has a very good blog explaining why that's not a great measure of long-term memory. So needle in the haystack is that you have a haystack, which is maybe a series of conversations or a series of turns, and then you try to find out the needle, which is maybe one specific thing in that haystack. So that's a more classic benchmark for long-term memory. LongMemEval goes beyond this, and it's maybe a little bit more natural. So you still have a haystack, which is a series of conversations, Sometimes many conversations on the order of 50 conversations, where each conversation's on the order of maybe a dozen turns or so. And these are natural conversations that you might have with very conversational, so not necessarily using tools, but just what you might have with ChatGPT. The questions are things like, how many musical instruments do I own? And this requires stitching together knowledge across several conversations. So maybe one conversation I mention, in the conversation, the haystack, the user mentions, oh, I got a guitar for my dad today. Maybe later the user says, oh, I sold all my instruments. And then maybe later it says, oh, I picked up a harmonica. And maybe later, oh, my brother gave me his instrument. And maybe elsewhere it says, oh, my brother plays the banjo, something like that. So the point is that you have to stitch together all these pieces of information. It's not as simple as just finding that one piece. And then how many instruments do I own? Oh, I have to put it together. Oh, I sold all my instruments. So it was 0 after that point, and then stitched it together, and the answer is 4. Even I lost track. It has a different, so that's one particular kind of questions it asks. It also has different categories like user preferences. So if you have an assistant and say, oh, if I go to Denver, what should I do? And if the assistant remembers, oh, the user likes live music and country, for example, oh, you should go to Red Rocks, this music venue. So it's questions like that. So each question has its own haystack, and there are 500 of these questions.
All right, great. Thanks, Marc. So that's a good overview of the benchmark. So let's get into this cool result. We achieved SOTA on LongMemEval. Can you give a high-level overview of the approach we used to achieve this result, and also try to contrast it with some of the existing approaches, what the previous best approach was, and how we're different from it?
I think we should probably start with the principal learning or fact that emerged or that is proven by this benchmark. And that is that if we take these 500 turns of conversation in a haystack and give it to one or several of the best models out there, O1, O3, for example, that they don't do so well. And we, just using memory in fairly simple ways, conversational memory in fairly simple ways, we're able to go past the performance of those language models when they were given the full context. So there's a proof that even for only 500 turns of conversation, and anybody who's had significant conversations with these models working on some problem, for example, knows that it doesn't take that many turns of conversation before it starts going off the rails. Having fairly focused small context, not 500 turns of conversation, is necessary for performance to even approach satisfactory. So when you look at the numbers, giving 500 turns of conversation to O1 or O3 only gets somewhere, what is it, Marc, 60 to 70% of the questions?
Yeah. So 60% for 4.0, roughly 70% for O3. And this is so these 500 turns, it's on the order of 10,000 tokens, which is well within the context. These guys have context windows.
Excuse me, no, it's 100,000 tokens. You said 10,000.
So some of the conversations are well within the 32,000 tokens. So just to be clear, there's LongMemEval S and LongMemEval M. For the S, we're looking at roughly 40 conversations per haystack, and each conversation is on the order of maybe 10 turns. The 4,000 turns, each one is maybe 20 tokens. So this will fit in the context window of these models. But still, these don't do as well. These do surprisingly poorly, given that this all fits in their context window.
Yeah, and in the case of O3, you're using a thinking model, so you would hope that it could attend over this and figure out the answers to the types of questions that Marc exemplified earlier. But it didn't in too many cases.
So I can add one more thing. So even before that, the previous competitor had 71%. So we just even tried a very simple technique where we even beat the latency. So latency is like basically the session per item, like how much time is it taking to retrieve the session per the second per item, and that result got around 76%. So that was the first breakthrough before the 86% went out. So in that, we just had a very simple turn level retrieval with some chain of thought prompting, and that was even able to defeat the latency of the whole system. Yeah.
Good call out. Good call out, Prakhar. So when we got unsatisfactory performance out of O3, giving it to Haystack, O3 would take 20 seconds to come back. That's not realistic for a user.
Yep, that is right.
One other point there is, so just off the shelf RAG doesn't do so well. So our initial we'll just take RAG off the shelf, feed it the conversations, and do a turn-based retrieval, just a very simple approach. This gets roughly 50%. So worse than out of the box 4.0 with full context. Now, in terms of like serious approaches to this before us, the state of the art before us was ZEP, which is quite sophisticated. So what they do is they ingest the conversations and build a knowledge graph, and not just a knowledge graph, but they essentially have dates on the edges. So standard knowledge graph, a lot of these questions require temporal reasonings. So build a knowledge graph, give them the haystack, build a knowledge graph, and then use this graph to put the appropriate information into the context window. It's much smaller than the entire haystack. And then get the answer. And ZEP gets 72%. And one other thing that ZEP does well is once you process the haystack, it's fairly quick to get your answers. They report roughly 3 seconds latency. So here's my question, and then wait 3 seconds for it to do its retrieval and spit out its answer. So much better than out of the box O3, 20 seconds.
Awesome, thanks. So we've published a bunch of the details behind this on blog posts on our website. But so you talked about some of the simple approaches like RAG out of the box doesn't do well. And even though some of these conversations might fit in the context window, simply that naive approach of shoving everything in the context window doesn't work well either. So let's get into a bit more detail. So what did we do to get to 86%? Was it like one or two headline techniques? Was it a basket of many different techniques? How did we eke out that gap?
I think first we should say that I think we approached 80% fairly straightforwardly. One of the important or insights that lifted the performance was to work on the granularity of how much, when you find something in the haystack, do you put just what you found into the context of the language model, or how much around that do you put in the language model? When we put the dozen or so turns in the conversation that we found in the haystack, so we do memory retrieval, we find some turns in a number of different conversations, and then those turns, those conversations have, as Marc said, 10 to 12 turns on average. So if we take that granularity and put that into the language model, that helps the language model resolve what's being said in an individual turn. And so that was one factor, and a significant factor, in lifting performance. When we went further than that, and also having a reasonable but still a simple and straightforward chain of thought, that said, hey, think about this, there's time involved here, think through time and things like that. All standard techniques and mentioned in the original paper by the authors of the benchmark. We're in the ballpark here. So just doing good, finding the right granularity and an appropriate chain of thought got us way past the prior state of the art. And then doing that increasingly well and using perhaps slightly better memory indexing and retrieval techniques is how we walked it up to 86.
Awesome. Very
One of
cool.
our results that just showed that it's possible to beat ZEP's, the prior state of the art, ZEP 72%, was almost cheating in a sense. So it's a chain of notes. So the idea is that you're given, so in the normal setup, the system is given the haystack and given some time to process the haystack offline. And then it's given the question and says, okay, given your processed haystack and the question, go answer the question, and your latency matters there. One early result we had was we said, okay, our processing of the haystack is we're just going to memorize the haystack. And then when we're given the question, we're going to go through the entire haystack conversation by conversation with the question in mind. And then, so this is sort of a chain of note approach. And so, okay, we'll take the first conversation by date. We'll take the first conversation, given the question, what's relevant from this conversation? What conclusions can we make? And we're only interested in answering this question, so discard anything irrelevant. Okay, given that, our conclusions from the first conversation and the question and the second conversation, do the same thing and keep this accumulating chain of note, keep this accumulating body of knowledge to answer the question. Well, this gets 82%. So it shows, okay, hey, it's possible to substantially beat the prior state of the art. However, the latency on this is horrible. So roughly 2 minutes, once you say go, 2 minutes or even longer to get back to your answer. But just that insight that, oh, okay, adding this chain of thought, chain of note is vital for doing well on this benchmark.
Very cool. Awesome. So let's turn a bit towards the future. I know one of the efforts inside the company is based on the observation that LongMemEval might not be the best benchmark when it comes to enterprise tasks or enterprise workloads. And we've been discussing the need for a better benchmark. So let's start with that and then also maybe talk about what the next frontier for agentic memory is. But let's talk about what kind of benchmark do we need to truly measure performance in an enterprise setting?
I
So
think one.
go
Go
ahead,
ahead,
John.
Mark. I was going to say, I think one next step is having some evaluation for what we might call process or procedural memory. So the LongMemEval benchmark is evaluating factual knowledge over the course of a conversation, but not all types of things you might want to remember fall into that category. In enterprise settings, it's crucial to remember tasks or processes or workflows that you might want to reuse. So one effort is to build a benchmark that accurately measures those types of memory.
There's one more thing which, when we talk about enterprise, is the tool calls. So basically, when you see that benchmark, it's very generic, general, and it does not apply to a lot of enterprise tasks. When we talk about enterprise or industry level tasks, we usually have tool calls. So it is very important to capture the tool calls, like which tools were used to access a particular process, as Jeremy just pointed out, or the workflow. So we need a benchmark which can also have that tool capture relevancy, that okay, hey, we went through this tool call to perform or to capture that particular workflow or like procedure. So tool call is going to be a very important aspect when we talk about enterprise.
Sure. In fact, we want to learn from experience, right? So, as some system or agent or whatever proceeds in some kind of automation, it may fail on one path, it may succeed on another path. Wouldn't it be great if instead of repeating that failure and the discovery of how to succeed, that we could harvest the skill that we learned and use that in the future? That's a core application of memory.
Makes sense. And Paul, you recently published a post on the site which zooms in on personalization performance for memory very specifically. So, talk a bit about that. What is the problem you're trying to solve? What is your approach there?
Personalization is an instance of what we started with. Remember, we started with you can't put everything, the context of the language model, and what you can put in to the context of a language model is very few terms because 500 overwhelms it. So you got to keep the context model focused. You can't understand a person by bringing in thousands of turns of conversation that you've had with them. You need to learn from those conversations about this person, just like I said a minute ago with skill harvesting. When you are doing automation and discovering how to implement workflows with agentic help, you want to learn those skills. So you have to look at that longitudinal history and extract or abstract something out of it. And then you have to put it somewhere. And then you have to retrieve it so you can use it in a more distilled form than the raw data in the context window of the language model. Personalization is a great example of that. You have to look at the turns of conversation, learn something about the person, remember it, and if the question involves personalization, as one type of questions in LongMemEval does, you need to use that personal profile in answering that question. If you don't, you're going to have the rubric for that is going to say, hey, you didn't realize that, like what Marc said, that this guy likes country music. If you don't remember it, you're not going to get the personalized question in the benchmark rate. So we did that. Pretty simple. We did that. Our worst performance on, we were state of the art on the benchmark across the board, but among the categories of questions, of which there were 5 or 6, there was this personalization category where we were state of the art, but it was our lowest performing category. So it was the perfect thing. Hey, memories aren't all the same. There's memory of a personal profile, there's memory of conversations, there's memory of passages of documents, there's all sorts of different memories. This is a great one to demonstrate, we're going to augment conversational memory with a second kind of memory, which is the personal profile, and we're going to demonstrate that its effect on this category of personalized questions in the benchmark. And that result's published. Basically, doing that lifted the performance on those questions significantly.
Awesome, very cool. Let's wrap up with a couple of quick lightning round questions, and I want everyone to answer. We'll go around the room. And my two questions are, what is the coolest next immediate thing you're working on specifically for memory? And the follow on to that is the longer term thing. What is your North Star goal for memory in agents eventually? So, Prakhar, let's start with you and we'll go around.
Sure. So I am working on assistant which can basically capture the long term. Basically, I'm in process of building the benchmark which we just discussed, like where it can capture the enterprise relevance, whether that benchmark captures questions which are grounded to realistic business tasks and tool calls. The biggest issue with the LongMem eval benchmark was it was not consistent. Like it had issues in certain tasks like temporal issues, and it has issues in the category of like personalized single user preference. So we need a benchmark which can measure, which can have that consistency check, like measure whether the assistant performs the similar task in a consistent and a reliable manner. So we need a benchmark which is reliable, especially for enterprise purposes. And that's it. And we need something which can capture the step-by-step reasoning for tool usage, workflows, and enterprise like procedural recall. So
Awesome. Paul, over to you.
So I'm in R&D, so I'm a little off the product path, but I've been working in this memory architecture space. I like what Zep did. We have something like that we applied to this benchmark and got in their ballpark without using the conversation at all, for example. So we just extracted all the information from the conversation. Some people call them facts. And then we indexed them. And just having the extracted facts without the turns of conversation got in the ballpark of the prior state of the art. So I work on that kind of stuff in the background. I'm building continuous representations of knowledge graphs towards automated ontology construction. One of the interesting areas is how do you use memory effectively? I'm not really ready to talk about this yet, but we think that memory and other kinds of agents observing conversation and using memory or interjecting content from memory or advice is an interesting architecture. So I'm beginning to explore that.
Awesome. Jeremy?
Yeah, so what I'm working on now is a process to extract workflows from a conversation, thinking about the best ways to store those workflows so they can be retrieved later and used in future conversations. So there are a bunch of kind of interesting issues that come up here, like what's the best format in which to persist a workflow? Is it natural language? Is it a kind of structured sequence of steps? What fields do we want to make available to the memory system about what workflows have worked before, including notes in those workflows? And then the second thing I'm working on is explicit cognitively inspired tools for memory processes to do recall, search through memory, and how those can be invoked by a planner at different points of the conversation.
Awesome. Marc?
So I'll start with the North Star, which is what I want is an assistant that automates all the tedious stuff for me. And where I'm in the loop, so I can guide it, but I'll have to take the wheel less and less often. And so long-term memory is a huge component of that, because every time I take the wheel or every time I have to explain something, okay, I'll take the wheel this once, I'll show you how to do it this one time, or explain it this one time. But if I have to explain it again, I start getting grumpy. So that's where I'd like to go. And then, so long-term memory is what I'm doing now is that, where I constrain myself to using the assistant to do whatever I'm doing, analyze data, file expense reports, whatever it is. And then where I'm forcing myself to use the assistant and getting the assistant to the point where I can just explain it in English. Okay, no, we use RAMP for our expense reports. And then it remembers for next time, it figures out the rest. And the other component of that, by the way, is just the connections, the authorization. Mundane plumbing, but that's what has to be done. Offloading as much as possible to long-term memory, having a core cycle, and then everything else is either memories or tools that the assistant itself has written.
Awesome. So thanks, folks, for a very stimulating discussion. And thanks, everyone, for tuning in. And we will see you next time. Thank you.